In this video we're going to look at similar shapes. Now similar shapes are shapes that are exactly the same but, okay, same shape but different size. That's the main thing here, different in size. So if you have a look at these two shapes here, exactly the same right angle triangle, but obviously this one has been enlarged. We've got two of the same shapes here, two isosceles triangles. This one has been shrunk to make this one. All right. So what we're doing is looking at the scale factor used to change them, and therefore we can actually figure out some of these unknown side lengths. So let's have a look first of all. I'll just try to focus this a bit more. Okay. So we've got this first shape here. We've got a 2.5, a 3, and a 4 centimeter side. Excuse me. And remembering we have to do our scale factor, and our scale factor is our new dimensions divided by our old dimensions. And what we will find if we do that is we have to be able to look for at least one set of corresponding sides that match. So we've got this side with a 5 centimeter dimension and this one with a 2.5. Now because of that pair, we can work and find the scale factor. If you look at this one, its corresponding side is unknown, and this one's corresponding side is also unknown right now. So we have to use the only pair that we have. All right, so our new dimensions are 5. Our old dimensions were 2.5, and that means if we go 5 divided 2.5, it's actually 2. So the scale factor we used was 2, which means we've doubled every side. 2.5 times 2 is going to be 5. So that means we can actually figure out our x value from our other sides. So remembering that to find x we need to multiply by our scale factor. It will be 3 centimeters multiplied by a scale factor, which is 3 times 2, which is 6 centimeters. So that means we can call this one 6 centimeters. If we have a look at y, we have to do the same thing. It's going to be this value, or 4 centimeters multiplied by the scale factor, which is 4 times 2, which is going to be 8 centimeters. So we know now y is 8 centimeters. We've applied the scale factor to get our new value. Now we can do the exact same thing. If we have a look at these two here, we've actually shrunken something. So we have to look first of all for corresponding pairs that have matching sides. Here we go, we've got a 6 here on this side and a 1.5 here. So we do have a matching pair of corresponding sides. We can find our scale factor. So the scale factor will equal our new dimensions divided by our old dimensions. We've got 1.5 divided by 6, and that means our scale factor is going to be 4. I'm going to squeeze this one up so we can see it a bit better. There we go. Okay, so we've got our scale factor of 4, and what we're actually trying to find firstly is x. So we're going to go, it corresponds with this value here. So x will equal 2.8 multiplied by our scale factor, which is 2.8. I've done this again. I'm so sorry. This is not 4 because that would be 6 divide 1.5. We've got to do 1.5 divided by 6. I'm so sorry. Same error. You can see it's a really easy thing to mess up there. So this is actually 0.25. Really sorry, guys. So 2.5 times the scale factor, this time it's 0.25. And what we actually get is 0.7. Remembering if something has become a smaller shape, then it's going to be less than 1. So that should have been a clue for me when I made this error to start with. All right, so we've still got to find out one thing, and that is theta. Remembering that theta is an angle. And what we're trying to look at is, okay, its corresponding angle over here is 25 degrees. So over here, I hate to break it to you, but angles don't change size. All right, so that makes it easy. They don't change size in similar figures, okay? In similar shapes. So therefore, in this case, theta will be exactly the same. Theta is going to be 25 degrees anyway.